This question, we have a graph yet again. So we do our analysis, Oi Zerga. We look at where the origin is, and we can see that this is a quadrant 1 situation. Y-axis velocity in the normal units, x-axis time in normal units. So we can read velocity and time values. Anything about velocity and time will be read. The slope is dividing the axes, delta v over delta t, and that is the acceleration. So anything about the acceleration is the slope, and v times delta t is delta x, the displacement. So the area is going to be delta, the displacement. Anything about the displacement of the position will be the area. So we have a straight horizontal surface, and we have the velocity time graph shown below. So what we see is over time, we have this velocity, and the velocity is increasing. So if there's some object, and it's moving over time, its motion dot diagram is going to look like this. It's going to show acceleration. Now, acceleration is the slope, and we see it's a straight line, so the acceleration is constant, because the slope is constant, which will determine the total displacement. Displacement is area between 0 and 5 seconds. So 0 and 5 seconds, we can bring this down like so. Now, one way to do this is to find this area. That's what we're looking for. So if we want displacement, displacement is definitely not about slope. Dividing the change in velocity by the change in time. Well, delta v over delta t is the acceleration. So we're not looking for the acceleration. Right now, since we're looking to select two answers, we might have found them as these last two. So finding the area, that's correct, area, bounded by the horizontal axis and the curve from 0 to 5 seconds. That's what we colored in gray. Using the average speed and multiplying the average speed 5 meters per second by a total of 5 seconds. Well, the average speed, v bar, is the final plus the initial over 2. And the final we see is 10, and the initial is 0, gives us an average velocity of 5, which graphically is this midpoint, 5. So if we replace this changing velocity of 0 to 10 with the average velocity of 5, and then multiplying that by the average speed, that gives us the area. And you will note, of course, that this area up here is equal to that area there. So they balance each other out. The area of the rectangle equals the area of the big triangle. So indeed, this and this are the two correct answers.